Now note that we can decide what radial basis functions to use. We can use some very wide ones or some very narrow ones. How do we decide? Well, this is a hyperparameter that we tune during training, and it is called the gamma parameter. And in a nutshell, a large gamma will give us a narrow curve like the one on the left, and a small gamma will give us a wide curve like this one on the right. In higher dimensions, this is very similar. A large gamma will give us some pointy mountains like the one on the left, and a small one will give us mountains looking like the one on the right. And this choice of gamma actually matters a lot in the algorithm. Picture looking at your data from above or after the projection. If you used a bunch of skinny mountains, then your boundary will look like the one on the left, where most points have their own little piece of boundary surrounding them. If you use wider mountains, then you would end up with something like the boundary in the right. And as you can see from the picture, large values of gamma tend to overfit, and small ones tend to underfit. And now, what is gamma? Well, here's where we define what these radial basis functions are. We'll use the Gaussian or normal distribution for this. The Gaussian is a very well used function in statistics that has this formula: y equals 1 over square root of 2 pi times e to the power of negative x squared over 2. In the general case, when we have a distribution of mean mu and standard deviation sigma, the formula is this, where mu is the very center of the curve and sigma is related to its width. So if sigma is large, then the curve is very wide, and if sigma is small, then the curve is very narrow. So in order to define gamma, we just use 1 divided by 2 sigma squared. Notice that as gamma is large, then sigma is small, so the curve is narrow, and vice versa. If gamma is small, then sigma is large and the curve is wide. In the higher dimensional case, this formula becomes a little more complicated, but as long as we think of gamma as some parameter that is associated with the width of the curve in an inverse way, then we're grasping the concept of the gamma parameter and the RBF kernel.